Hello, everyone. It's great to be here with you guys at this wonderful conference. There is a bright future for energy and new technologies that are developing now. It's amazing what's emerging, and it comes from a very deep level of physics that are being explored and uncovered at this point by many scientists around the world, physicists and engineers. And there is new understanding, a deeper understanding of the physics of unifications. Unification meaning that these new physics unify gravity with quantum physics, or Einstein field equations with quantum theory. These two fields are typically separate, and they have a big chasm between them. A chasm that many scientists around the world have tried to build a bridge across, including Einstein till the day he died. Literally a few hours before he died, he was working on unifying quantum theory with relativity. And this chasm is starting to get filled, and it emerges from a very important new concept, a very important discovery, although this discovery was made almost 100 years ago. But it was kind of buried in the physics, and it's re-emerging now. And really it has to do with the way we think about the structure of space-time.
As you talk about more about vacuum energy, delving into new technologies which are more novel, single problem solving. So we still don't have a panacea for all the energy related problems the world is facing right now. So how do you think, as a physicist, we could integrate all these novel technologies? And obviously there's this collaboration part which comes in, but what can we think on the not so obvious part, like from a physicist point of view?
From a physicist's point of view, right, to integrate these new technologies.
Absolutely.
Yeah. Well, the really interesting part about vacuum energy engineering is that it can be seen, it can be visualized that some of this technology could literally initially be plugged into the current grid and replace nuclear power plants, coal plants, diesel burning plants, hydroelectric dams, and just use the current grid structure to power our world. So it's very practical. There's no and from the 25 years I've been doing this, I've seen multiple devices, from mechanical devices that are simpler to more advanced esoteric devices that are that are based on plasma physics. And so there's all kinds of different gradients in which this can emerge, but certainly there's some results that are already present in the world, and then eventually I think it will become clear that the grid is no longer necessary. That is, you can get these vacuum energy devices to run your car, to run your house, to run your devices, to run everything you've got. And so the grid is no longer necessary, which is really important because the grid is a very weak point of our civilization. It's very vulnerable to any electromagnetic disturbance. For instance, one solar pulse in the right direction at the right time, at the right moment, could black out a large portion of the world, because all of the transformers on all the poles, those cans you see on top of the poles, are very sensitive to electromagnetic pulse. And so, and it's happened before. For instance, in Canada, Quebec and Ontario were plunged into darkness. I think it was in the 80s when there was a solar flare that hit it square on and blew most of the power grid. And luckily it was in the summer, so nobody died, or minimum people died. But you know, if it would have been at minus 40 in the Canadian winter, it would have been a disaster.
Disaster, absolutely.
Yeah.
So more of a follow-up question to what you were already talking about. So how do you think the academic level readiness among students of science and technology should be to, you know, come up to the level of vacuum energy?
Well, that's a big problem. That is a big problem. It has been a long battle for me and many others. You know, anything that's that new, that far outside on the bleeding edge of physics is usually pushed back on quite a bit. And so it's difficult to get the professors, even the students in some cases, to understand that this is actually very much real, and that it is a field of physics that's evolving, that's transforming, and that's emerging. You know, if you look at the theory from Leonard Susskind, that is the director of the Stanford physics department, you know, called ER equals EPR. ER means Einstein-Rosen, and EPR means Einstein-Podolsky-Rosen. And so ER is Einstein-Rosen bridges, or wormholes. And so basically the theory says that wormholes, ER, equal EPR, and EPR is entanglement, showing that wormholes, which are Einstein's consequences, relativistic consequences, are actually occurring at the quantum level, and that's what's entangling particles. And so this is very much related to what I'm talking about, the holographic principle, how like a particle is not individualized, but it's connected. So it's connected through wormholes at the quantum level, Planck scale wormholes, and so that everything is entangled. So you know, this it's there, it's solid in there in the mainstream, at the very bleeding edge, you know, of the mainstream. And so it's very hard for some professors and students to like get involved, because there's a lot of skepticism. So that is a big milestone that we have to overcome, is to get people to understand, no, this is real physics, there is real physics being done, and there's amazing possibilities out of it, and to get people excited about it. You know, so it's a big issue, and it takes a lot of courage.
Sure.
For the students and the professors to get involved.
Sure. So one of the most simplest yet so profound questions on climate change is, 30 years down the line, am I safe if I'm living in a coastal city or town? Am I safe? What do you think on that?
Well, it depends how fast we can develop these new technologies, and how fast we can get the world to come along and stop fighting it and go with it. You know, that will make a big difference. I would say in the current state, you're not. You know, you're not safe at all. But I'm hopeful and enthusiastic, and and I see the light at the end of the tunnel, and I think we're gonna get there. So hopefully, I mean, we're literally talking about gravity control. You understand that? And you know, gravity control is the next step for human evolution. I know that, like, you guys are all pretty young and you haven't seen this whole evolution. You know, you're born with iPhones in your hands. You know, us older guys, we've seen more of the evolution, but still not that much. But, you know, in 150 years of modern civilization and industrial era, we basically learned to control, understand deeper, and control electromagnetic fields, which give us all of our civilization, you know, electricity, communication, transportation, all this stuff. So this as well, you know, is now a new step for the evolution of humanity. And it's to understand better and learn to control gravity is the next step. And when we do that, now we have gravity control, then, you know, we might consider that living on the surface of planets is not the right thing to do. It's not the safe thing to do. Even Stephen Hawking has been talking like that for the last 10 years, and he did get a lot of tomatoes thrown at him for saying that. But it's true, and he's correct. We have to find a way off the planet soon. Because planetary systems are not going to necessarily stay stable for eternity. Eventually they get hit by a comet, a meteorite, one big sun flare, boom, the atmosphere is gone. You know, I mean, but if you have gravity control, then it's a whole other ball game. It's a whole other story. You can build spaceship the size of, you know, planets, you know, the size of cities. You know, you can gather material from the solar system anywhere you want. You can get water, ice water from other planets. You can, like, all of a sudden everything opens up, because if you can control gravity and direct it the way you want to direct your vessel, then, I mean, you can literally go to Jupiter for the weekend. So it's a whole different way of living in the world, and it probably is the birth of a space civilization that doesn't ever really live on planets, but comes to planets as like a place to go, like you go to your garden or right. to the park, you know. But you don't put cement all over it. You don't necessarily live on it. You just allow it to be natural and beautiful, and when you come to it, it's to enjoy it.
Sure.
So it might sound really far in the future, but I would suggest to you it's right around the corner.
Sure. So now, more of a geek question. You as a physicist, do you think nuclear energy can be seen as a potential replacement for the thermal power as an entire you know, base load generator? Like, can it wipe out the
nuclear energy?
Sure. Mm-hmm. Yes.
No, the idea that nuclear energy is clean is very erroneous. It's nowhere close to being clean. In San Fe, right here down the road from where I am, they're burying nuclear waste right there on the beach. You know, any earthquake or tsunami or anything like that can create serious chaos, and it could take out millions and millions, billions of people. There's inherent risks with nuclear power that has nowhere close to the connotation of a clean source of energy. And so it is not really a viable path. I mean, really, like, when you consider that you're doing all this nuclear fission to literally boil water and run turbines, and the efficiency of it, it's really not, it's not a path that is sustainable for humanity. At one point, if we continue to do that, there will be an issue, and it could be a global extinction issue, like what happened at Fukushima. What is going on at Fukushima is nowhere close to over, and it is producing a lot of difficulties. And the fact that we have it somewhat contained, although we're still dumping millions of gallons of irradiated water in the Pacific Ocean, is like this kind of stuff is just nowhere close to being able to be labeled clean or sustainable. And so I think we have to steer away from nuclear power plants. Most of the advanced physicists, Einstein included, said it was the most ridiculous idea. It really, there is other possibilities, and these possibilities are so much deeper in their application and in their consequences for humanity, that it's really worth the effort to investigate. Because really, at the end of the day, instead of colliding protons, you just got to figure out what was the source of the energy that produced a proton in the first place. And that's what we're discovering. So if you tap into that, then you're tapping into the fundamental source of creation. And, then you're actually aligning your technology to the natural forces of the universe instead of fighting them.
Sure. Well, this is a more personal favorite question. So, I mean, in the recent past, for the past 2 weeks, what the southern coast of the United States has been seeing, microgrids seem like a fairly decent option for a fallback, especially in these storm-flattened communities. So do you see some kind of dark horse technology which can actually complement microgrids, especially with these geostorms being more frequent in the near future?
Yeah, absolutely. Again, like vacuum energy and over unity devices. Over unity devices, which stems from vacuum energy, a lot of the scientists are going to say those are not possible, right? They output more energy than is being put in, because they appear to violate the laws of entropy. Some of them appear to violate the laws of motion, like the EM drive is something people should look up. But they don't. It's just that the laws of entropy and the laws of motion are written in the context of a closed system. So these laws start within a closed system, and then you look up closed system and in a physics dictionary, and it will start with no such thing has ever been found, right? Nothing can be completely isolated from the universe. And what we're discovering is that there's this field of energy that's permeating everything, and so you cannot isolate. And so these over unity devices are not violating the laws of entropy and motion. They are just tapping into a field of energy that we didn't know was there before. Just like Faraday figured out that if you move a magnet relative to a coil, you can get an electric field that nobody knew existed before. And then they go, oh, this could be useful, right? Just the same way, right? This vacuum energy that we didn't know was there, or we ignored, although we discovered it theoretically, now could be the source that powers all of our devices. And so these microgrids, it would lend itself perfectly to microgrids, especially the mechanical ones, so that small communities that are isolated due to various, cataclysms or anything that disrupt them, they could have these hubs, with a small grid system that powers a very small community, and these hubs would be the energy density of these over unity devices is very high. So the device can be very small and produce enough power for a fairly large community. So they lend themselves very much to that idea, very, very well to that idea.
Sure. Doctor, so keeping time as a factor,
Right.
I think we'll end that there. Any message you want to give to our audience about the
Yeah.
future
Well,
of energy?
if you're a student out there or a professor, please, take the time to explore this new field of science, this new field of physics, and don't discard it offhand because it's on the bleeding edge or because it's not square inside the mainstream. Much of it is actually square inside the mainstream, but it's unknown, unclear. It is very exciting. I believe it holds the key to the future of humanity, and we need you to help. If you're writing your PhD thesis in physics, if you're writing, your master's, if you're exploring the engineering at high level of space exploration, whatever, this is where it's at. This is where it's gonna go. I guarantee you that. I certify that is the salvation of humanity, and we will get there. And so we need your minds to help out with this. We need your energy. We need the new generation to understand that we must transcend the current state of affair, and we will not transcend it by continuing to go in the same direction that the standard model and the older generation has gone. It's time for the new blood to come in and not necessarily just swallow whole what is being said and taught in the educational institution. So it takes a lot of courage, but and you can do it inside the institution. You just have to be very diligent, and you have to be careful about how you do it so that you don't upset too many apple carts. But it's critical that you get involved, and it's critical that this new generation pushes that field forward and bring us into a sustainable society for the future of humanity.